Hello, this is Carl Machiavelli here. I want to talk a bit into mathematics because I'm currently sitting on exams right now and I have to learn the Cholesky factorization, which was horrible for me at first to learn because of these formulas. I'm trying to focus it so you can see it. Maybe it's visible. Let's see. So basically the Cholesky factorization means you have a matrix A which is symmetric and which is of size n times n. And you can split it up into a factor of a lower left diagonal matrix together with its transpose version. So basically it's calculating the square root of the matrix, if you will. Now, the problem is these fucking formulas. They are horrible. So, the way this is usually taught, it's either you write the formulas and you just hit and pray, if you can remember them all, or how other university teachers teach this is fucking autofocus, dude. Is you create a matrix L11, let's say, and you write this all down, and then you transpose it, write it all down, and then you set it equal to A, and you try to calculate it by basically remember the formula by calculating this whole matrix. Like, let's say this is N1 and you write N1 here, etc., and you try to like make a diagonal matrix like this and a diagonal matrix like this and try to calculate A out of it. And this way you are supposed to be remembering the formula more easily. Which is, I don't know about you, but this costs a lot of time. And I'm not sure if I'm the only one or the first one having come up with this, but at least if you can see my textbook, this is the stuff I have to remember for the exam. And I found out a much simpler way of calculating the Cholesky factorization by writing the matrix of the left lower diagonal matrix while calculating all of the L values. So instead of like doing all the work remembering formulas, like calculating all the L values and reconstructing the matrix based on all the L values you have collected, you can do it in parallel. And we can start easily. I can show you this is the matrix we want to go with. And fuck! This is a bit hard with a phone in my hand. Right, looks like a mess right now, but fuck it. Anyways, what we are going to do is we are going to write L directly like this. And we are going to write the first value, which the first value, L11, is just the square root of A11. So this is going to be L11, as you can see in the formula right here, pretty easy. This is going to be 4. And so the next row, the Li1, basically means the square root of this row. This is also easy to calculate. We just take the values of this matrix and plug them in here, but before we do that, we divide it by the first L value, L11. So 8 divided by 4 is going to be 2, 4 divided by 4 is going to be 1, 16 divided by 4 is going to be 4, and 20 divided by 4 is going to be 5. And so now we can look at the formula just to basically prove we don't need the formulas at this point anymore, but just to prove that this method works. Is now you're supposed to take the L22, you're supposed to use this value and take the root of the A22 value minus the L21 value to the squared. And so we can just look at this matrix here, 5, and we are going to subtract 2 squared, so this row squared by the 5, everything we have written in this row right here. And so this is 5 minus 2 squared is 4, and the square root of that, we take the square root of that, that is 1, because 5 minus 4 is 1. And so now we have a much more disgusting formula, right? We have Li2 is Ai2 minus L21 minus Li1 divided by L22. So what this means, is it even the, yes, it's the real formula. So what this means is basically we're going to take this value right here, this is 4, and we are going to make a sort of line right here. And so what we're going to divide for each of these values, coming from here, 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 is we are going to divide the row we are putting the value in together with the original row, so the column. So to demonstrate, we are going to take the 4 minus 2 times 1, so we multiply this together with this because we're in this row and in this column. So 4 minus 2 times 1 is 2, and we're going to divide it by 1, which is 2. This right here, this value right here, 11, we are going to multiply this row because we're on this row together with this factor right here because we are on this column. So 11 minus 4 times 2 is 3, so divided by 1, our answer will be 3. 14. Would you mind? Fuck. So we have 14, right? We are on this row and this column, so we're going to take this value. 14 minus 5 times 2 is 10. No, wait. 14 minus 5 times 2 is 4. So we're plugging this right in here. And now we're going to get to the really disgusting formulas. LKK equals fucking hell. Right, now. AKK minus the sum of from j equals 1 to k minus 1 of LKJ to the squared. So, simply put, we are going to take this number right here and we'll see where we're going to put it on the same position. So here we have the 14 and we are going to subtract the square root of each of these in the row. So 1 times 2, like 1 squared minus 2 squared, 14 minus 1 is 13 minus 4 is 9, and the square root of that is 3. And so another way to, this is basically an analogic function or analogic formula to what we calculated here, right? We were on, when we calculated this value, for example, we were multiplying this row because we were on this item because we were on this row, and this item because we were on that column, right? Remember, this like wall that we drew. And so with this value, it's the same thing, right? So we're going to multiply the elements of this row and the elements of this column. So that's why we're going to take it as a square. So, this video is getting long, but whatever. I don't have a real camera. So, we have 16. Same principle here. We're going to put the 16 here, but first we are going to do 16 minus 4 times 1, because we're on this row, this column. 16 minus 4 times 1 is 12, minus 3 times 2 is 6. So we have 6 here, but we're going to divide it by 3. And this is going to be 6 times, yeah, this is 2. Right. 22. 22 would go here, but first we're on this row, this column. So 22 minus 5 times 1 is 17, minus 4 times 2 is 8. Wait. Alright, 22 minus 5 times 1, 17, minus 4 times 2 is 8. Ah, that's 9, my bad. 9 divided by 3 is 3. Alright. So, 30. I'm pretty sure you know the formula by now, but because we're on the same row as in the same column... fuck. I didn't want to do that, but... take the 30 out of here, and we calculate 30 minus 4 squared is 16, so 30 minus 16 is 14, minus 9 is 5, minus 4 is 1, so the square root of this is 1. 40. We're going to draw the imaginary line here as well. 40 minus 20 is 20, minus 12 is 8, minus 6 is 2. 2 divided by 1, we're dividing by the corner again, is 2. Lastly, 55, finally. 55 minus 5 squared, because we're on the same row and same column again, we're going to take 5 squared, is 30, minus 16 is 14, minus 9 is 5, minus 4 is 1. So we're going to put a 1 in here, and we're done. And we just have to write the LT basically, and times LT is equal to A. And this is how we did the Cholesky factorization. Of course, this is a bit of a longer video, because I did a lot of explaining and visualizing with these like cross markers, etc. But once you get the hang of it, it will be much more quicker and much less how do you say? Much less likely you're going to have a much lesser likelihood of committing any errors because you memorized the formulas wrong, or you did some miscalculation when trying to calculate it by hand by doing some origami shit or whatever. So this system, I believe, is a much easier way and much simpler way to calculate this off the bat, and you're going to save a lot of time if this happens to be in your exam. So, if you don't believe me that this result is correct, before I made this video I already calculated this by hand just to make sure I get my explanations correct, etc. And this should be... right. Should be it. So, you can check for yourself. Thank you for watching.